Question number 21 says, which of the following operations can be used to convert an alternating current dynamo into a direct current dynamo? So how do you convert an alternating current to a direct current? So first of all, your direct current is simply a unidirectional flow of electric charge. That's what your direct current is. So you have an electric charge that is being allowed to flow in only one direction. Okay, so a typical source of a DC is your battery. Okay, so your alternating current flows in multiple directions. It's not flowing in a single direction. And so what you want to do is to be able to convert that multiple directional movement of electric charge into a single directional movement of electric charge called DC. So to do that, you need what we call simply a rectifier. Are you getting it? And the principle or questions you could use to achieve that is one of those things that we're searching for in this question. All right, so if you have you could have the draft like this. So you have I, V, and then you have time. Then let's say you have a flow like this. Don't mind my drawing too much. So this is an alternating current. That's an alternating current. Then if you have something like this, a flow that is just seamless, single straight line, this is a direct, don't let me use that pen. This is a direct current. This one is an alternating current. So you could have some sort of pulsation. So you could have some sort of pulsation right here. So this is what you could call a pulsating. So there's simply, you notice that from the diagram that we've shown, it's just a sketch anyway. The direct current is just that guy that goes in a very straight line, just one single direction, and your alternating current flows like that. Okay, so now to be able to achieve your conversion from a direct current, so you could, option A says number of turns in the circle is increased. If you increase the number of turns in the coil, that's not correct. The strength of the field magnet is increased. That's not correct. Slip rings are replaced with a single ring or commutator. So that is correct. So your DC, if you call your direct current a DC, so you can have DC or an AC, alternating current, can be converted into a direct current by what? Replacing the slip rings by replacing the slip rings by a single, or with, let me use with a single, this one is a split with a single ring. So you have this one to be split with a single ring, or single ring commutator. Okay, so with this you'll be able to achieve your conversion successfully. We're given a diagram and it says net capacitance in the circuit above is what? The net capacitance in the circuit above is what? So the circuit given looks like this. So we have something like that. We have the capacitance of a capacitor, and then we have it like this. So both of them come together like this, and then join up with another capacitor like this. So this is what we've got. This one is 2 microfarad, 2 microfarad, and then this one is 2 microfarad, and then this one is 4 microfarad. Okay, so this is the circuit that we got. So to calculate the equivalent capacitance in the circuit, we will first of all do the ones in parallel, and then we will now join it up with the one in series. So this guy and this guy are in parallel, so we'll do the equivalent of the ones in parallel, then we'll now do the one in series. So for a parallel connection, the equivalent capacitor is equals to C1 plus C2 plus C3 plus C4, depending on how many capacitors we have. So here the equivalent capacitance would be equals to 2 plus 2, which will be equals to 4. So now this would now give birth to something like this arrangement. Now you have a 4 and then plus another 4, the original 4 that you have there. So you have 4 microfarad now, and then another 4 microfarad. Both of them are now in series. Okay, so now to get, so we can call this one CT1, actually not this entire CT. So the overall CT now would be equals to as you can see, this is now a series connection. So for series connection, the reciprocal of the equivalent capacitance is equal to the summation of the reciprocals of all the capacitors in the circuit. So you have the 1 over C total to be equal to 1 over C1 plus 1 over C2 plus 1 over C3, like that, depending on how many numbers of it you have. So 1 over C total will now be equal to 1 over C1, in this case is 4, plus another one is 1 over 4. So a quarter plus a quarter, that will give you an half. So 4 in 4 1 plus 4 in 4 1. This is 2 over 4. 2 here 1, 2 here 2. So you have 1 over C total to be equal to 1 over what? 1 over 2. So if you cross multiply now, you have 2 equals to C total. So your C total is now equal to 2 microfarad. 2 microfarad is your C total. So if you look at your option, your D will be your option. So